Good morning. This lesson is for my Integrated 1 class, but before I get started, I want to say I hope that everyone's doing all right out there. I'm not sure how I'm going to title this lesson, but I'm going to title it how I title it in the title. But what I am sure of is our one goal for the day. And our first and only goal is to solve other types of two-step equations. And let me just remind you again of why this series of lessons has been created. I was asked a long time ago by a student, how do I know what to do first? How do I know what to do next when solving equations? And it was a really good question, and I didn't have an answer. But I had to tear down and rebuild what I had so I could answer that question. And this series of lessons is going to answer that question. And right now we have 5 steps to solve equations, which I'll get into here in a second. But the ultimate goal of these steps is to give the students a starting point, knowing what to do first, and then knowing what to do next. And hopefully through repetition and recognizing what each step looks like through how it's written with the clues and the directions, a student will become proficient and confident at solving equations. So let me get back to the lesson here. I would like to review the concept of like terms. Like terms are terms that you can combine. I forgot the word that, but that's okay. Here I have 5x minus 3. These are not like terms. We cannot combine them. So it has to stay as 5x minus 3. I can't put them together. They're not like terms. 5x minus 3x are like terms. If I have 5, I owe 3. That means I have 2 x's remaining. So I can put these together because they have the same variable. Those are like terms. 5 minus 3. These are also like terms. These are like terms because I can combine them. I can put them together. I have 5, I lose 3. That means I have 2 remaining. So these 2 examples are like terms. This first example is not. All right, so hopefully that clarifies it. So now let me read the updated list of steps to solve equations. The first step, which was a one-step step, is to eliminate fractions by multiplying everyone by the denominator. Our second and third steps are new steps. Our second step says combine like terms on each side of the equal sign. So here's what we're looking for on each side of the equal sign, things that we can put together. Our third step, get all variables to one side of the equal sign. We use addition or subtraction like we do in step 4. So how we move numbers to the other side of the equal sign using addition or subtraction in step 4, we do that in step 3. Step 4 again is a one-step step. And we add or subtract away a number from the variable side of the equal sign. And again, we're looking for a clue that we have a plus or a minus between the number and the variable. And finally, our fifth step is to divide away a number from the variable side of the equal sign. There's nothing between the number and a variable. That's how I know that I'm going to do step 6. But by the time you get to step 6, it should be quite clear that you're going to have to divide away that number. All right, so I have a couple examples and comparisons of the new steps 2 and 3. And you'll notice that I wrote the same equation twice, and I'll explain why in a second. But I'd like to go ahead and solve this problem. What I recommend for my students, or for you watching if you're struggling, I would recommend writing 1 through 5. For now. It's going to be 1 through 6 during the next lesson, but for now we're going to write 1 through 5. And I would like to just go through and look at my steps. If I can do this step, I do it. If not, I move on. As simple as that. So, step 1. Can I eliminate a fraction by multiplying everyone by the denominator? Well, this equation has no fraction, so I can't do step 1. So now I move on to step 2. Combine like terms on each side of the equal sign. Which means, do I have like terms on each side of the equal sign? Is there anybody I can put together over here? And as we just saw, yes I can. I have like terms. So I can do step 2. I can put my 3x together with my 5x. I don't change signs, I just put them together as they are. And I get 8x now is equal to 16. That's what step 2 looks like. Okay, we combine like terms on each side of the equal sign. I can have like terms on this side, but for this example right now, it's on the left side. All right, step 3. Get all variables to one side of the equal sign. Well, let's see. Do I have all variables on one side? It looks to me like all the variables are on the left side, so I can't do step 3. Step 4. Can I add or subtract away a number from the variable side of the equal sign? Do I have a plus or a minus between my number and my variable? No, I do not. I have, in fact, nothing between my number and variable, so I must do step 5. So I'm going to divide both sides by 8, divide away the number from the variable side. I need 2 8s to get to 16. I get x equals 2. Now I've solved for x. I've isolated. Now I'm just going to check really quick. Again, we check in the original equation. Okay, so blah, blah, blah. We have 3, and I'm going to replace the x with a parentheses. 5, I'm going to replace the x with a parentheses. And that's equal to 16. Inside the parentheses, I'm going to put a 2. 3 2's gets me to 6. 5 2's gets me to 10. 6 and 10, that gets me to 16. And I know that 16 equals 16 is a true statement. So I have a solution to my equation. This again is what step 2 looks like. Again, notice they're all on the same side of the equal sign. All right, let's move on to problem number 2. I'll do this in a different color so it stands out a little bit better. All right, so again, I would recommend writing steps 1 through 5. 1, 2, 3, 4. I'm going to put 6, but not that lesson yet. All right, so again, I go through the steps. Do I have a fraction that I can eliminate? Well, this does not have a fraction I can eliminate, so I don't need to do step 1. Step 2, can I combine like terms on each side of the equal sign? Let me draw a little dashed line through the equal sign so it's very clear who's on the left side. No one on the left side except 3x, so I can't combine anyone over here. And I can't combine these because it's like the first example I had over here. So I can't do step 2. All right, I can't do that. Step 3, do I need to get all variables to one side of the equal sign? Yes, I do. And I need to use addition or subtraction like I would do in step 4. So here I'm going to move the 5x to the other side. This is a positive 5x, so I need to subtract it away to both sides. Minus 5x, I can do this. Minus 5x. Minus 5x, there we go. All right, so if I have 3, I owe 5, that means I still owe 2. So minus 2x. Minus 2x, these cancel out, is equal to 16. I need to look at my 4th step because I just did my 3rd step. Do I have a plus or minus between my number and my variable? For the 4th step, no, I do not. I cannot do that. I can, however, do my last step because there's nothing between my number and my variable, so I divide away the number from the variable side. So I'm going to divide away the negative 2. So divide away the negative 2. That means x is equal to, I need negative 8 2's to get to, 2 goes into 16 negative 8 times. Right? Because a positive divided by a negative is a negative, so negative 2 divides into 16 negative 8 times. All right, I need negative 8 2's to get to 16, which I am not going to get into. But let's go ahead and check this now. Again, everywhere that I have an x, I'm going to replace it with a parenthesis, and I'm going to drop in a negative 8. So here I have 3 negative 8s. Is that equal to 5 negative 8s? Take or add 16 to that. Well, 3 negative 8s gets me to negative 24 because a positive times a negative is a negative, and that's 3 times 8 is negative 24. 3 times negative 8 is negative 24. 5 times negative 8, that's going to give me to negative 40. And negative 40 plus 16. I owe more than I have, so I know my answer is going to be negative, and it's actually going to be negative 24. So here I have negative 24 is equal to negative 24, and that means that my answer is correct. All right, so this is what it looks like to have variables on both sides, and using the step that I used in step 4 to get the variable to the other side. Now, if this was a minus 5x, I would have to add it to both sides. Now, I wrote the same problem twice because I've seen this done many times. Students, you know what your move is going to create because I see this done quite often, and some of you guys want to avoid this negative. So I'm going to write my 5 steps to solve right now, and I'm just going to go through them, and you'll see the difference that I do. So can I eliminate a fraction? No, I cannot. Can I combine like terms on each side of the equal sign? No, I cannot, because there's nothing for me to combine over here, and these are not like terms. Can I get all variables to one side of the equal sign? Yes, I can. Let's say for this problem, you decided to move the 3x over. Because I have a positive 3x here, there's nothing in front of it, I do the opposite like I would on step 4, and I'm going to move the 3x to the side. Well, I have 3, I owe 3, that means I have nothing left. Don't put 0x, just put 0. The 0 is going to be equal to 2x plus 16. Okay. So now we have an added step, because now my 16 has a plus between it and the x. So now I have step 4. I've added a step to my problem because I moved x's towards the side of the equation with the numbers. You want to move x's away from the side of the equation with the numbers. But you're not wrong if you do what was done here to avoid a negative. You're just now going to have to deal with this number. So I have to do step 4 because I have a plus between the number and the variable. So I'm going to subtract 16 to both sides. Alright, that cancels out. I have nothing. I owe 16. That means I still owe 16. And 16 equals 2x. I've done step 4. I still have a number with a variable, so I must do step 5. And I divide away the 2. 2 goes into negative 16, negative 8 times. Now, I'm not going to check this because I just checked negative 8 and I saw that's the right answer. But I wanted to show you that you could avoid an extra step. See, this had 3 steps to this 2-step problem, because we moved the variable to the side of the equation that had the number, where on this one, we moved this one to the other side, and we moved it away from the number. So I do understand that this happens because we want to avoid the negatives, but they're still going to get you the same answer. You're just going to add an extra step. I would like to come back and work through a couple more problems so you can see the 5 steps in use. So I wanted to highlight the new steps 2 and 3. I'll just come up with a couple more problems to solve and check. So let me clean this up and I'll be back. I'm back, so let's just go ahead and do these couple problems and wrap up this lesson. So again, I want to give examples of going through the 5 steps that we have so far to solve equations and show you how I would use them. So again, I would write 1 through 5 next to my problem just to reinforce that I know what to do first and I know what to do next and I can answer that question. Alright, so I'm going to look at my problems and compare it to the directions. Step 1. Can I eliminate fractions by multiplying everyone by the denominator? Yes, I can. So I'm going to multiply u by 2, I'm going to multiply u by 2, and I'm going to multiply u by 2. So this 2 and this 2 cancels each other out, and now I'm just left with an x. 2 4s means that I'm left with an 8, and 5 2s means that I'm left with a 10. Step 2, can I combine like terms on each side of the equal sign? Can I put these together? No, I cannot. Is there anyone to put together with this? No, there's not. Can't do step 2. Are all my x's on one side? Yeah, all my x's are on the left side of the equal sign, so I cannot do step 3. Step 4, do I have a plus or minus between my number and my variable? Yes, I do. I have a plus sign between my 8 and my x, right? And let me say it again. Can I add or subtract away a number from the variable side of the equal sign? And on the variable side of the equal sign, I have a plus between my number and my variable. So I can do step 4. So I have to get rid of a plus 8, so I'm going to go minus 8 to both sides. Alright, one side and the other, that cancels out. I'm left with x is equal to positive 2. I have 10, I owe 8, that means I have 2 remaining. I've solved for x, x is by itself. Now I can check. So again, I write my original problem, replace the x with the parentheses, plus 4 equals 5. Put my value of x in the parentheses. I need 1, 2, because 2 goes into 2 one time, so that's going to turn into a 1. 1 plus 4 is equal to 5. 1 and 4 gets me to 5 equals 5. So you can see that I used my steps. I stopped at step 4 because I isolated it. Didn't need to do step 5. And again, this was a guide to work me through the problems. Let me move on to the next problem. Alright, so I got my first step, my second step, third, fourth, and my fifth. Step 1, do I have fractions to eliminate? No, I do not. There's no fractions, can't do it. Step 2, can I combine like terms on each side of the equal sign? I can't combine anyone here, I can't combine anyone there, so I cannot combine like terms on each side of the equal sign. Step 3, are all my variables on one side? Yes, they are. So I don't need to do step 3, I don't need to get them to one side. Step 4, can I add or subtract away a number from the variable side of the equal sign? Do I have a plus or minus between a number and a variable on one side of the equal sign? I do. The 5 has a plus between it and the x, so I can get rid of that positive 5 by subtracting 5 to both sides. Alright, so let's see here. I owe you 4, I owe you 5, you're going to tell me now I owe you 9. My 5's cancel out and I'm left with 3x. Well, I got a number with a variable with nothing between it, which is exactly what step 5 requires me to have in order to do. I think I said that right. So I need to do step 5 and I'm going to divide both sides by 3. 3 goes into negative 9, negative 3 times, because a negative divided by a positive is a negative, and I get negative 3 is equal to my x. Let's go ahead and check this. Again, I go back to my original. Negative 4 equals 5 plus 3 times negative 3. Alright, I can multiply these first. So now I'm going to get negative 4 plus 5 minus 9, because 3 times negative 3 is a minus 9. 4 equals 5 minus 9. If I have 5, I owe 9, I still owe 4. And negative 4 equals 4. I've got an answer because I'm left with a true statement. So x equals negative 3 is a solution to my equation. One more to go, and again, I'm just going through the steps. 1, 2, 3, 4, 5. If I have it, I do it. If I don't, move on. 1, 2. I'm going to do this in a different color. The bell's going to ring any second. I'm hoping to finish this lesson before the bell rings because it's going to get really loud and it won't be able to hear me. All right. Step 1, do I have a fraction I can get rid of? No. Step 2, can I combine like terms on each side of the equal sign? No, I cannot. I can't put anyone together with the 8 because it's by itself and x and 3 are not like terms. So I can't do that. Can I get all variables to one side? I don't need to. All my x's are on the right. Can I add or subtract away a number from the variable side of the equal sign? Yes, I can, because I have a plus sign between my 3 and my x. So I can get rid of this plus 3 by doing a minus 3 to both sides. Alright, then I'm left with 8 minus 3 is 5. The x, nothing happened to it. The 3 and the minus 3 cancel out, so now I'm just left with 5 equals x. I don't need to do step 5 because x is by itself. This was a one-step problem, but I figured it out by going through my steps. Alright, so let's check this thing. So now I'm going to write my original equation, which is 8 equals, instead of the x, I'm going to put a parenthesis plus my 3. Inside my parenthesis, I'm going to put a 5. And so now I just have to combine these like terms and see what I get. So 8 equals 5 and 3, that equals 8. And that is a true statement. So again, I want to reinforce, I'm going through my 5 steps in order to work my way through the problem, answering the question, how do I know what to do first? How do I know what to do next? We had to learn the one-step problem so we could do the first set of two-step problems. I've added 2 more steps so we can have another other types of two-step equations to solve, and this was it. So I hope this is making sense. I hope that we're starting to understand that there is a process that we can follow to solve this, and it's not, math is not something that some people can do, it's something that all people can do. So hopefully this lesson was helpful. Again, I hope everyone is doing all right out there. Have a great day, everybody. Bye-bye. I beat the bell. It's going to go off any second.